Alrighty, hello, how's it going? So I'm sort of midweek and I just wanted to blow off a bit of steam. So today's session, it's just going to be a little bit of fun. I have started working with the new cohort of graphics programming students. And the other day in one of my labs, I ran through a demonstration of OBJ files and the vibe was good. So I figured I'd just run through that again. So this is super beginner level. We've just started OpenGL going from the ground up. So I've got some code here and I'll go ahead and include that in the video description. But right now, I don't want to worry about these top three functions. This job of like setting up Pygame, creating a shader, creating a buffer. We can treat those as black boxes. What I'm really interested in is when we display stuff on the screen, how do those screen coordinates work? And how can we start, I'm going to start with a point, then we're going to make a triangle, and then I'm going to talk about the OBJ model format. So I'll sort of draw your attention to these lines here. I have a list of lists for positions, and it's X, Y, Z coordinates. So every one of these elements, currently there's only one, has three components. And then likewise, I've got a single color. That's red, green, blue. Okay, I'll just go ahead and run this and show you what it looks like. As we can see, we've got a single, this is a point, but I've really zoomed in to make it more visible. But it's just here at the center of the screen. So the first thing I'm going to talk about is the way these screen coordinates work. In Python, in OpenGL, these screen coordinates are limited from -1 to 1. So if I were to go back and modify this, and for the X coordinate, put in -1, and then run this again, we can see that this point has moved to the left of the screen. Likewise, if I were to go back and change that to 1, the point is now at the right of the screen. So we can see that X coordinate runs the gamut from -1 up to 1, where -1 is the left of the screen, +1 is the right of the screen. So now what I'll do is I'll reset that X coordinate to 0, so we'll be at the center, and I'll start varying the Y coordinate. So currently we can see that we've got a Y value of 0, and like I said, it's going to go from -1 to 1. I guess the big question is, which corresponds to which? So this can vary according to the graphics API, but in OpenGL, -1 corresponds to the bottom of the screen. You can see that there. Now I can go back in, just to verify, and I can go in and say, okay, let's put in 1, and that's now at the top of the screen. So what I'm going to do is I'm just going to, let's say we want to make a triangle. Making a triangle. Okay, well, I want to put in a point which is the bottom left of the screen. So I'll go ahead and make -1 for left, -1 for bottom, and then I'll put in a point which is the bottom right. So 1 for the rightmost point, -1 for the bottom, and I'm not even talking about the Z coordinate at the moment. I'll just leave it as it is. We'll leave that, it's fine. And then I'm going to have center top. So we'll have 0 for the X, that'll be centered, +1 for the Y, that's up at the top, and we're just going to leave in that 0. So those are my positions. I'm going to put in some colors to match this. And I'm just going to keep it nice and simple. This is the classic triangle that I think everyone draws when they first learn OpenGL. It's all fine. We all start somewhere. And I'm just going to have the bottom left corner red, the bottom right corner green, and the center top corner blue. So the way these work is each of these components represents a color channel, red, green, or blue, and they're normalized between 0 and 1, where 0 is like no contribution on that channel, and 1 is full contribution. So hopefully looking through here, you can see we've got 3 colors are defined, and we've got full red, full green, full blue. Okay, so I'll go ahead and run this. And yeah, that's what we can see. We've got these big old points and they're squashed in there. Okay, that's looking pretty good. So the reason these points are really big is if we look down at this line here, I'm setting the point size to be 32 pixels. This line is not super important. I'm just going to get rid of it. And right down here where we draw this data, currently I'm drawing in points mode, but I can get in there and change it to something else. So let's draw in lines. We go ahead and run this. Now two interesting things are happening. Number one is the color is varying from one point to the next. So OpenGL handles this. The graphics card is doing this for me right now. What it's doing is it's putting in those individual points and then it's filling in between those points and it's interpolating every single attribute. So it's interpolating the position. See, the position's changing from the bottom left to the bottom right, but it's also interpolating the color. And if I put in different types of data in addition to the color, those would probably be interpolated as well. But the other interesting thing is we've only got one. Now, what's happening here is every pair of points forms a line, and I think it just doesn't like being given 3 points. Let me just see if this makes any difference. I think we can do line strip. This is just off the top of my head. Does that work? Sort of. We've got another line there. But this is okay because I'm not going to stay here for long. Let's not do lines. Let's fill these in and make triangles. Okay, cool. So we've got 3 points. Those 3 points are taken in to form the corners of a triangle. And then just like with a line, all attributes are interpolated over the area of the triangle, over the interior area. Now this is fine, but it'd be really cool if we could load in model files. One of the most common model files, especially for beginners, is the OBJ model file format. It has the benefit of being a plain text format, which means you can load in an object model, open it in your text editor, have a look at the data that's in there, and you can even, if you want, write your own. So that's what I'm going to do now. So I'm just going to a new file. I'll call this model.obj. Now I know that I'm calling this model.obj, but the fact is that there's nothing special about the OBJ file format. It's a plain text format. Whatever I type in, I'm defining the model format right now. So what I want to do is I want to essentially take this data and define it in my model format. So right now I'll just worry about the positions. What I'll do is I'll put in an identifier to specify the sort of data that I'm providing on this line, and then I'll have the data. And this is how I'm going to define a position. We'll have the line start with V for vertex, that's a position, and then everything will be separated by spaces, and we'll have the X coordinate, the Y coordinate, and the Z coordinate. So like I've got down here, I've got one position, which is -1, 1, 0.0, nothing fancy here. I'm just copying out the data that I've written. 1, -1, 0, and then 0. Okay, so I'll just go ahead and save that and maybe a little bit of space. Okay, so what I would like to now do is, instead of hard coding these positions, I would like to make a function which takes this in and reads it. So I'm just going to make my function, which I'll call read model, and then I'll put in the file name for the model, which is model.obj, and then I'm going to read it. So just up above, I'll go and define that function. And just a little note here, in my demo that I made here, I've just gone ahead and defined vec3 as a custom data type this is just for fun, just for code completion. Okay, so the first thing I want to do is basically load the model. I'll load the file, open the file for editing, and I'll do that like this. I'll say file equals open, and then I'll put in the file name and the mode I'm reading, so that'll be R, and then right at the bottom I'll do the following. I'll close the file, and I'm also going to have this list, which as I look through the file, I'll start populating that with my positions. But okay, so right now we've got, where was I? Right now we've got this file, we've opened the file. One thing which is really good to do is just print out the contents of the file one line at a time. So I'll say, let me go, line equals file read line. Okay, so what this is doing is we're continually reading a line from the file. Now, when we reach the end of the file, that'll give us an empty string, which will evaluate to false, and that'll get us out of this while loop. But yeah, so we just read once to get started, and then deal with what we got, and then read the next line. So let me go ahead and give this a shot. And I forgot to save. I'll try that again. Okay, cool. So we've got no data, we're drawing nothing, but we can also see that we've looked through the file and printed its contents out one line at a time. So that's really cool. The next thing is I can see that all the data in the line is separated by spaces. So the way we can separate a string in Python is with the split function. So we get the line and we split it, and the token that we're using to split is a space. So then, yeah, I'll just go ahead and print out the result of that. And we can see that, yeah, for each of these, we are getting, yeah, we were splitting things off nicely. Now, what we can see is that the first element of the words variable is always tracking the tag of what that line is meaning, basically. So what we can do, we can say get the tag, and then if we've got a V, then that's a vertex. So what I'll do is I'm just going to be a little sneaky and do a list comprehension here, but I'll talk through it. What I want to do is I want to pick out each of the other things in that line. So this is like, we'll call it words 1, words 2, words 3, and I want to convert each of those to a float and then bundle that together in a little list. That's my little vector there. So operation I'll be doing is converting to a float the ith word, and then the range of those is starting at position 1, going up to but not including position 4. And just to verify that this worked, I can then go ahead and print. So that is looking really good. I can see that every time I've gone through and converted these into floats. So I'm getting the float data out from that. So I'm happy with that. What I can do now is I can go ahead and throw that into my data set. So I'll just verify that that's working. It's looking good. So now we've got the triangle, but let's extend this a little bit. So I'll go back up, and as you can see, I'm currently sort of using this to get my positions, but I'm not doing anything with my colors. I'm just thinking to myself, okay, yeah, let's do this. So what I'll do is I'll just go up and I'll make some other tags which are going to define colors. So a color tag will start with C, and it'll pretty much be the same as before. So I should probably note that I'm not strictly adhering to the OBJ file format. The purpose of this is to make a case for OBJ models from first principles just to show like how this stuff works. The Wikipedia article for OBJ file format does a pretty good job of explaining how it actually works, the for real file format. But what I want to do is I want to go through here. I want to get out the positions and the colors as two separate lists. So I'm going to just change this, and this will be my position data. And then I'll also have color data. Now, this is the case where we have a V tag, and the case for a color tag is pretty similar. So I'll just go through and I'll say, okay, well, if I see a color, then I'll call this color. It doesn't matter. It's just a temporary variable. But again, it's the same thing, right? We're just getting 3 floats, and I'll go ahead and append that into the color data set, and then I'll return both of those. So hopefully you can see this is pretty similar, just a straight copy paste. I'll just go down and I'll use that to get the colors as well. So not super exciting, because if this works, we're getting, ooh, that is actually interesting. Okay. Oh yeah, okay, because can you see the mistake? So this is just taking the last vertex which was defined and putting it in there. And I don't want to do that. Okay, now this will work. Cool. But the really cool thing, I don't know, is this interesting or not? But the really cool thing is we can go in and we can change the data in our file, and then the thing that we load looks different. I think that's pretty cool. So this is a pretty good start, but there's one more thing. Let's say we want to make a quad, and I'll just bring this up. Okay, get ready for some scuffed drawing. So here's a quad, a quadrilateral. It's, oh my goodness, this is bad. This is bad news. I'm using a drawing tablet. This would be easier with a mouse. So here's my quadrilateral. But the issue is that in OpenGL, legacy OpenGL supported quads, but modern OpenGL does not. And so every polygon, every shape needs to be decomposed into triangles, because triangles are a lot easier to work with. So let's say that I've got a bunch of positions, all right? So this is position 0, bottom left. I'll say position 1 is bottom right. Position 2, I'm going to shift over, that'll be top right. That's really bad. And then position 3 will be top left. Okay, so what we could do is we could redefine these positions, right? Because position 2 is like on this triangle and on this triangle. But it would be better just to define all the data and have that as like sets floating around in memory, and then pick from that and use it to assemble the triangles. So let's say that those triangles are defined. First, I'm going to pick the corners 0, 1, and 2. That will build one triangle. Then I'll pick the corners 2, 3, and 0, and that will build the second triangle. So hopefully you can see how this matches up with the diagram, and I'm going to get this out of the way and sort of get into it. Okay, so first of all, I'll go ahead and modify these. So this will be, I'll go bottom right, and then I'll make another corner, which is the, sorry, top right, which is the top left. And then I'll just go ahead and make another color, something like that. It doesn't matter. Now, next thing I'm going to need is I'm going to need to sort of declare some faces. So I'll put an F to declare a face, and then I'll say, okay, well, which indices are we going to use? So I'm going to use indices 0, 1, and 2 to make one face, and then I'll use 2, 3, and 0 to make another face. So I'll just get that all, there we go. Okay, so now I'm going to modify my loading code. So I'm actually handling the V and C just fine at the moment, except that I'm going to make copies of these. So I'll say I have a bunch of positions, a bunch of colors, and I'm going to, instead of directly inserting into my data, my output, I'm going to insert into these. So you can think of it like what I'm doing right now in the V and C stages is I'm building up a collection of all the positions and colors. I'm going to draw on that later when I assemble my faces. So now I'll say, all right, well, what happens if we get a face tag? Okay, now you can probably see I'm making a lot of assumptions right now about the OBJ file format. In a second, I'll talk about how it actually works. But I'm going to pick out, oops, yep, the set of indices. And just like before, I'll use a list comprehension. So let me see, words I, okay, just like before. And then I'll say, let me just do this for now. Intermediate stages. Okay, so what I want to do, I'm predicting that if this is working correctly, I'll have a list with the integers 0, 1, 2, and then I'll be looking through those one at a time. So first I'll have that index variable at the value 0, and then 1 and 2, and so on for the next line. Okay, yep, easy mistake. That should be 2 equal signs. Okay, I'll give that another shot. Okay, awesome. So this is acting 100% the way I expect it to. So as we're going through this for loop, first we got the index 0. And what that really is, it's a command to pick out the vertex number 0 and the color number 0 and put them in my results. So I'll say, okay, that's looking good to me. Haha, except it's not. Look, I have experience. That doesn't make me immune to typos. There we have it. Cool. So we've looked through, we've assembled those shapes, and yeah, got what we're after. So there's obviously a lot that I've skipped over. So let's start looking at that. So actually what's happening is for some reason in the OBJ file format, right now these indices are 0 based because that's how lists work, that's how arrays work, that's the normal thing. But that's not the default in the OBJ file format. So they're actually 1 based. So we'd actually see this. And obviously if I try to load this data, I'll now have an error because we've got a maximum element of 4, but we've got 4 elements, which means anything from 0 to 3 is valid, not 1 to 4. But thankfully, this is an easy fix. All we need to do is I'll just go down to this expression where I'm generating the set of indices, and I'll just add this -1 offset. Okay, looks good. Now, this is going to be a little trickier because this is great if everything matches up. If the vertex and the color are actually fine. But in general, that's not how the OBJ file format works. In general, we have indices for every attribute and they're separated by slashes. So this is, even for the same data, this is how that would look. So then this gets a little more complicated, but we can totally deal with it. So I've just zoned out for a second. I'm thinking of a concise way to do this, but sometimes, what is it they say? More haste, less speed. Let me think of a non-concise way to do this. So I'll say for I in range 1 to 4. I'll say print words I, and I won't worry about anything else right now. Okay, so as you can see, the elements here are separated by slashes, and the first thing here is the vertex index, and the next one is the color index. So what I'm going to do is I'm going to go ahead and split these based around that. Yeah, based around this slash symbol. And now when I run this, I see, yep, I'm separating those pretty well. So what I'll do is I like to name this sort of thing by the attributes that it's indexing. So the first element here will be the vertex, second element will be the color index, and I'm going to go convert this to an integer. I'm going to look through the elements there. So the temporary variable x, the first time it'll be the text 1, the second time it'll be the text 1. And hopefully that works, and I can verify it by printing. And that looks like it's working. So I'll go ahead and offset to take care of that off by 1 error, and then I'll look through this. So use the first element there, which is the index, into the vertices, use that to access the vertices that we loaded, put it into the set of positions, and do the same thing for the colors. So that would be VC second thing index 1. Okay, fingers crossed. Yeah, awesome. Okay, cool. So there we have it. Now, there's one more thing, and I'm not going to demonstrate it, but I will talk about it. And that is, right now I'm making the assumption that every face is just a triangle. But in reality, in the OBJ model format, every face has the potential to have more than 3 corners. So one time I was loading a gun model from Blender, and it had a 19-sided polygon. So if we can make general code which can accept those sorts of things, then that's really what we should be doing. And yeah, all the usual caveats. So this is the basic idea of an OBJ model. OBJ models don't actually have color attributes. That's why it's giving me these errors here. Typical attributes are texture coordinates and normals, but some of those are optional. Sometimes they're not included. So this has just been my little first principles demonstration of object models. I hope this wasn't too intimidating. If you can open up an OBJ model and look at it and sort of understand what's happening and sort of load it in, then that's a really good start. I just want us to feel confident and get into it. So look, that'll be it for now. Hope you had fun, and I will see you again soon. Hey, so I just want to take a second to give a really big thank you to all of my channel supporters. I really appreciate it. It just blows my mind. Supporting financially, that's a boss move. So cicadas. Okay. If you like the work that I do and you would like to support me financially, it's $2.50 a month. That is all I ask, but it really does make a difference. If you're not willing or able to support financially, probably the best thing you can do is the usual: like, comment, subscribe, let me know what stuff you're liking. And yeah, so without further ado, a massive thank you to Antonin Karet, Putfinka, Dankyo Foles, Declan, Endelon Studios, Gadania, Gary Deshen, Mathieu Derick, Moim, and TSL GPT. GPT, I don't know about that. But thank you so much, my dudes. I really do appreciate it. Hope you're going well, and I will see you again soon. Bye.